Hey everyone, welcome back to another session of Quadratic Formula. So in this session we're gonna discuss the case-based questions, and let's start without wasting any time because I don't want the videos to be long. Okay, so the first question here is the Raj and Ajay, they are very close friends, and both the families they decide to go to the Rani Khet by their own cars. Now Raj cars travel at a speed of X kilometers per hour while the Ajay's car travel 5 kilometer per hour faster than Raja, right? And Raj took 4 hours more than the Ajay to complete the same journey, that is 400 kilometer. And the first question is, what will be the distance covered by the Ajay's car in 2 hours? So let's not go to the first question directly, let's try to write everything that is provided. Okay, so first, whatever is provided about Raj, I'm gonna write that. So the speed for Raj is provided, so I'm gonna write it as SR, which is X kilometers per hour, right? And the speed for Ajay is provided. Let me see if it is coming in the frame or not. Yeah, it is coming in the frame. So speed for Ajay is, let's say, SA, and which has to be more than 5 because it is given, right? Like more than X by 5. So it is X plus 5. Correct? X plus 5 kilometers per hour. Now, of course, we can see that the speed of Raj is less than the speed of Ajay, and since both are covering the same distance, so distance will remain common, which will be 400 kilometers, right? Okay, 400 kilometers. Now the next part over here is that Raj took 4 hours more. Of course, because the speed of Raj is less, so he's gonna take extra time. And let's say the time taken by Raj is TR and the time taken by Ajay is TA. So TR is greater than TA, right? So what will be TR? TR will be distance upon speed. Correct? Speed is equals to distance upon time, or I can say time is equals to distance upon speed. Similarly for Ajay, it will be 400 upon X plus 5. Right? Now it is also given that the difference in the time is 4. Right? So I can say TR minus TA will be 4. So TR minus TA will be 4. Clear? Okay, so if you want, you can solve it and then check the first option or the first question, or if you want to check it right now, you can check it directly because I can see the questions still have X and X, right? The answers still have X and X, means they haven't solved it yet. So what is the distance covered by Ajay's car in 2 hours? Okay, that's an important thing. So distance covered by Ajay, that is d of A, right? It is speed times time, speed multiplied by time. Now speed for Ajay is X plus 5 kilometers and the time is 2, right? 2 hours. So this will be the correct option, first option. So with this we are done with the first question, and let's see the second question. Find the following quadratic equation describes the speed of the Raj's car. So for this, of course, we need to solve the equation, and solving the equation seems easy over here because you can see 400 on the left and 4 on the right. Yes, so yeah, I can take common and let's write this upon the same thing. I've just taken 4 common and I can simplify it and this. Okay, so is it solved? No, not yet. So I'm gonna do the LCM. I'm gonna take the LCM and solve it accordingly. So it will be X plus 5 minus X upon X square plus 5X. Yes, is equals to 1 upon 10. Now ready to solve. So it will be 500 is equals to X square plus 5X. Now if I look for the option, this 500 will come to the other side and it will be negative 500. So do I see any option like that? Okay, X square plus 5X. So this is the option, right? C. Correct. Now, so we have this equation. I'm just gonna erase it If you have not noted, you can just go back and write down the equation. Okay, now we can solve this using the middle term splitting, or we can also use the discriminant, whichever you find easy. So what we can do here is, let's try using the discriminant. Can we do that? We can, right? Or we can also use the middle term splitting. We want 500 as the product, and how can we do that? What if I have 25 and times 20? Yes, so 25 times 20 will give me 500, and the difference is also 5. So since I get this, so I'm going to use the middle term splitting. Yes, now look at the sign. I want a positive 5x. So obviously the bigger number has to be positive. So x plus 25 minus 20, x plus 25. So answer can be either 20 or negative 25, and you know we can eliminate this option, and we got this. Now what is x that we supposed? It was the speed of Raj, right? So Raj's speed is given to us as, we got it as 20 kilometers per hour. Speed of the Raj car, 20 kilometers. Now what about the next question? How much time Ajay? So time for, okay, how much time Ajay? Okay, so now we know that speed of Raj is 20 kilometers. So the speed of Ajay will be 25, correct? 25 kilometers per hour. Now if I consider this and time they are asking for, so we know that speed is equals to distance upon time, and since they are asking for time, so that will be equals to distance times speed, right? So distance is of course 400 kilometers. Sorry, that's what I was doing. Okay, so speed is equals to distance upon time, and time will be distance upon speed. And what we can do over here is to 400, which is the distance, upon the speed, which is 25, right? Can we do that? Yes. And if you solve it, what will you get? Yes, it will be 1, right? And 25, and if you solve it further, you will get 15. So 150. And how can you get 150? On 6. So 16 hours. Or the other way to do it, you know that the speed of Raj is this, right? So I can find the time taken by the Raj, right? Time taken will be 400 upon 20. That will be 20. And the time taken by the Raj will be 4 less than 20, which is 16. So you can do either way, okay? Alright, so with this we have solved these 4 problems, and this question is actually important because in exams, if you get case-based question on quadratic equation, then chances are you will get questions like this. Okay, another question which is a very important question, which is based on upstream and downstream. So the speed of the motor boat is given to us as 20 km per hour. So speed of motor boat is 20 km per hour, right? And for covering a distance, now distance is also given, which is 15 kilometers, right? So for covering 15 kilometers, the boat takes 1 hour more for the upstream than the downstream. So this is again the concept of upstream and downstream. Now it's not only the motor boat speed that we need to consider. If you look at this, okay, I won't zoom it, okay? So it is like not only the speed of boat, but also the speed of the current that matters, or the speed of the stream, right? So we know that for the upstream and for the downstream, we can just actually write it in this way. For the upstream and downstream, the speed will be different, right? So upstream means going against the current or the wave, right, or going against the stream, and downstream is going along with it. So for the upstream, let's say that the speed of current be x or the speed of stream be x. All right, let the speed of stream be x kilometers per hour. So for the upstream, the speed for upstream will be correct 20 minus x, because it is going against, so the speed will decrease. Whereas for the downstream, it will be 20 plus x. Yeah, so we got the speed for the upstream and the speed for the downstream. Now what they have given next is the boat takes 1 more hour. So it's very clear, when the speed is less for the upstream, then the time for the upstream will be more than the time for the downstream, and the difference is also given, that is 1. So I can say that the difference between TU and TD will be 1, right? Correct? Okay. So let's see the first question. Let the speed of the stream be x kilometers, then the speed of the motor boat upstream. So motor boat upstream will be 20 minus x kilometers per hour, right? And downstream it will be 20 plus x. What is the relation between the speed, distance and time? So we know that speed is equals to distance upon time. So speed is equals to distance upon time. Okay, let's see the next. Okay, so now we have to check for the equation, and that can be solved if we, use this information and write our equation. So TU will be distance for upstream upon speed for upstream, and TD will be distance for downstream upon speed for downstream. Anyhow, the distance will remain same, so there is no point of writing DU or DD. Correct? So I can just write it as D. So TU will be what? Distance. Now distance is 15 and the speed is 20 minus x. Okay, TD is again 15 upon 20 plus x. And the difference in both the times is this. Make sure you're putting the bracket. This is really very important. Alright, otherwise you will land on with the wrong answer, because you have a negative sign in between, and you know that if we have a bracket and if there is a negative sign, it changes the sign, right? So take the 15 common. We are having now 20 minus x minus 1 upon 20 plus x equals to 1. Let's solve it further. So it will be 15 and then 20 plus x minus 20 minus x, or I can solve this bracket and write 20 plus x. Alright, so this will be 400 minus x square equals to 1. Or I can just transpose this here and I can cut this, and I'm left with 2x, okay, upon 400 minus x square is equals to 15x, which gives me an equation of 30x is equals to 400 minus x square. Yes, I can transpose it to one side and it will be like, okay, I can transpose this to the left side and it will be like x square plus 30x minus 400 equals to 0. Any way you can transpose. Right? Yes. So with this you got the equation. Now how do we solve it? So we have 400 as the product, and I can get this when if I have 40 and 10, and if I subtract I'll get 30. So these two are the numbers which satisfy the equation. Or yeah, sum as positive 30 and product as negative 400, and if sum is positive, so this should be positive and this one should be negative. So let's write it in this way. Yeah, so I got this. And of course this should be equals to 0, so x minus 10 and x plus 40. So we have two options, x to be positive 10 or x to be negative 40, which is not possible. So the value of x, or the value of the current, or the speed of the current or the stream will be x kilometer per hour. Now, how much time boat takes in downstream? So T of D is something that we already know. T of D is this, and you have 15 upon, I got x as 10, so it will be 30. Yes, so the time taken for the downstream will be 1 upon 2, that is 30 minutes. This is half hour, right? So half hour means 30 minutes. Alright, so with this we are done with the two questions. Alright, and these two questions is all that I wanted to discuss. Of course, we still have to discuss about the age related problems. Then we have to deal with some questions which have digits in them, or sum of digits like this, product of digits like this. So we have to deal with such questions, and that will be in the coming sessions, part 2, part 3 and part 4. And in part 5 I'm planning to get to the very basic of the quadratic formula. I know I'm going in a reverse way, but still I feel like that is also important to show you how the discriminant works, how do we get distinct real roots and imaginary roots, and how we use the middle term splitting. So method of solving the quadratic equations and the nature of roots or zeros that we get. Yeah, so let's meet in our upcoming sessions, and I hope you like the session and it is actually of some help to you. Okay, bye bye.